Hello friends, in this video lecture we will see common gate configuration. In previous lecture we have seen common source configuration. Here we will see common gate configuration. We will find DC gain, output impedance, input impedance and transconductance of common gate configuration. So common gate configuration can be make like this. So this is ground or at some VB voltage, some DC voltage, DC bias voltage. This is output, this is VI. This is known as common gate because gate is common to output and input. So here, so this is VO and common gate. So this is here VI is R out. Now let's first find out transconductance GM of circuit. So again we will ground this. We will find ISC upon V in, ISC upon V in. Now we will draw small signal. So this is RO and small signal GM, VGS. This is VI, this is gate, this is source, gate is ground, ISC current here. Now VGS equals to this will be minus VI because VGS equals to minus VI. So again we draw small signal. It is like this, GMVI. Here we are changing direction of current and making this negative sign to positive. This negative sign to positive by changing direction of current. So it will be like this, ISC, this is VI. Now if we apply KCL at output node, ISC equals to VI upon RO plus GM VI. So GM equals to ISC upon VI equals to 1 plus GM RO upon RO. If GM RO greater than 1, then GM equals to GM. So here for common gate, GM is positive GM, and previously we have seen for common source it is minus GM. Now second thing, R out, output impedance. So this is the configuration. We make this input VI ground, this is RO. Here we will apply VX. Here there is a load resistance, say here we are considering idle current source which is infinite, but let's take some load resistance and find out RO. So VGS here is 0, so GM VGS term equals to 0. So RO and RL come in parallel. So VX upon IX R out equals to RO parallel RL. If RL, say for idle current source infinity, then R out equals to RO. Now third, DC gain. ADC equals to GM into R out. GM is GM R out is RO parallel RL. So here in common gate configuration we can observe that it is not giving inverted gain like common source, because here sign is positive, and in case of common source here sign is negative. So this is DC gain. Okay, now let's see one more thing. Input impedance R in common source input is at gate, so it's infinite, but in case of common gate configuration it is not infinite. So for finding impedance, input impedance, we will apply Vx and find out Vx by Ix. So here Rn equals to Vx upon Ix. Here if we draw small signal, so this is RO, then Rn, then parallel to this Gm VGS, which is minus Gm Vx. So this is Vx. So further we can write it, make it like this. We can make it like this. This is so we can make it like this RO, and we change direction of current Gm Vx. This is Rn. So this is Vx, current is Ix from Vx. So this is Ix current. So here Ix current will come out. If we apply KCL at this point, then Vi up minus, so say this is Vo, Vx minus Vo, Vx minus Vo upon RO plus Gm Vx equals to Ix RL. If we solve this, we will get and Vo equals to Ix into RL. We put this in this equation and we will get Vx upon Ix equals to RO plus RL divided by 1 plus Gm RO. So it will be RO 1 plus Gm RO plus RL divided by 1 plus Gm RO. It will be 1 by Gm plus RL plus intrinsic gain of MOSFET Vx upon Ix. This is Rn equals to like this. Okay, let's plot this. So this is y-axis, this is x-axis, RL, this is Rn. So it will be something like this. So this is 1 by Gm, and it increases as RL increases, but RL here is divided by intrinsic gain actually. So you can remember how Rin varies with load resistance. It will vary like this graph. Thank you.